You can turn the 3 reviews on test and the counting principles if you haven't given that to me.
I'm saying like probability part 1.
I think I want, actually maybe those 2. I think I want them all.
1, 2, and 3.
Yeah, I want 1, 2, 3,
I did
the
all
3 reviews, and the counting principles.
I thought you.
But you can turn them in on test it.
I thought you said you didn't assign me.
I did not. That's not one of them. Yeah, I did the one that says math team that's kind of in the middle of all these reviews. I didn't assign that one.
So there's still.
Counting principles, probability 1, probability 2, probability 3, and then there's 3 reviews. One that says review, one that says counting and probability, and one that says probability. But you'll see it if you look. Yeah.
Can you do like on page 113, number 5?
Yep. And one thing that might help you guys as you're learning this, say things like a great question would be, well, why is what I did wrong? That's a great question to ask because I can point that out if your thinking's just a slightly little bit off, you know? So number 5 says, how many ways in a game of straight 5-card poker am I able to get 3 tens, 2 jacks, and 2 other cards? Now, did I say that the other cards had to be different kinds? I mean, no. So they might be the same kind. They might be different kinds. Are you with me? All right. I didn't say, and 2 other different kinds of cards. That would mean that the other cards can't be the same kind as well as being different from tens and jacks. So I didn't have to choose 10. I know I'm getting tens. I'm getting 3 of them, 4C3. And then I'm getting 2 jacks. I didn't have to choose jacks. So of the 4 jacks, I'm getting 2 of those. And then the 2 other cards, well, how many cards are left that aren't tens or jacks?
44.
44? So technically, any of those 44 I could get, couldn't I? So I'm just going to pick 2 of the remaining 44. And it said how many ways, not probability. So I'm out.
So whenever it says how many ways, you don't have to divide things.
If you're using combinations.
Okay.
So this is why that's not true, that statement. What if I said this? Well, there's 4 tens I could pick on the first choice, then 3. So that's me getting a 10 and a 10. And then 3 tens. And then 2 on the third choice. So that's the number of ways to get a 10, a 10, a 10. Number of ways to get a jack, 4, and then 3. What's wrong with this? Yes, the order here, evidently getting this 10 first and this 10 last is different from this 10 first and this 10 last. That's not a true statement. The order in which I get tens and jacks doesn't affect my outcome. I still have tens and jacks, right? I haven't even gotten to the last 2 cards yet. Point is, if I wanted to fix that right here, I could fix it by saying, well, if I just divide by 3 factorial, 2 factorial, essentially, I just made it a combination because that's the only thing. 4C3 is technically this, right? This is how we learn the definition. But what that simplifies to is 4 times 3 times 2 over 3 factorial. That's what that simplifies to. Because the 4 and the 1 cancel. I wouldn't do it that way, but it would cancel and leave me 4, 3, 2, and then the extra 3. Well, that's what I just did right here. 4, 3, 2, extra 3.
Wouldn't you have to add like the not?
Yes, I haven't gotten to that. Then for the not, I could say, well, there's 44 that aren't, and then 43 that aren't. And
Why don't you divide it all by 2?
and I'm going to divide that by 2 factorial for those 2 as well. But this is the way I would have done it. But I just want to point out that this is a harder way to think. I think tens, jacks, not either of those. But I have to go back and do this because it's not probability. If it's probability, I got a 52C7 down here.
What's the difference between finding how many ways and finding the probability?
This is finding how many ways.
How many ways do you count? There are 6 ways to organize line 3, but the probability of them being organized in some way is
Like if I said, how many ways can you draw a king from a deck of cards? 4. What's the probability that happens? 4 over 52. How many ways can this happen? That. Or this. What's the probability that it happens? I would have to divide by 52C7, which is the same thing as
The difference between the likelihood and the number. That makes sense.
that 52C7 is all of that and the 7 factorial. But if I say how many, I would just do this, but you technically could do that also.
A lot more thinking though.
It's a lot more thinking. The only advantage of knowing this kind of thinking, which you are not going to have to deal with on this guys, was what if I said with replacement? Well, with replacement, now it's independent, right? So you don't have this option.
You'd have to do it that
You
way.
would have to do this, but what would every one of these numbers be?
4,
And this would be,
52.
oh,
Oh.
yeah, no, it would be. No,
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 it's-
because
because it still can't be
Yeah.
tens and jacks, so it would be 44, 44. But I won't ask you that, because I'm not gonna force your hand this way on how many. You can do how many with that though. What else?
Maybe number 9.
Number 11, 110.
You said 19, and I'll do number 11. 19 on what?
You do have
119.
80% of numbers.
Hold on one second, one at a time.
So number
19 on what?
119
On 119?
is, I have one of those, why was what I did wrong?
Okay, so probably getting 3 of a kind 2 different times when I pick 7 cards. So I want 3 of a kind, and then evidently there's 1 extra card, right? Because it's 7.
I should say what I did, 'cause it's wrong, I checked the key,
Go ahead.
it's pretty far off. I did 4C1, so like picking the first kind, and then 13.
4C1 didn't pick a kind. 13C1 could pick a kind.
So, yeah, I reversed it. I did 13C1 and then 4C3.
I'm writing down what he did. And then what?
4C3, like you're picking 3 out of the 4. And then I did 12C1. It's like you have to pick a
Right.
different kind. And then 4C3 again.
You did that?
Yeah.
Okay, this is why. 13C1, when you simplify it, is that. 12C1, when you simplify it, is that. 11C1, when you simplify it, is that. 13, 12, 11 is the same thing as 13P3. So what you just did was a permutation. What you said was the order in which I pick the 3 of a kind and the 3 of a kind and the 1 of a kind has an effect on the outcome, but it doesn't. Now it might at times, like for instance, queen, 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 jack, 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 ace. That is not different than that. So what that means is I can't go 13, 12 when I'm picking the 3 of a kinds.
You have to say 13, 13.
No, I gotta pick, instead of going 13P2 to do 13, 12, I need to do 13C2. Because the order doesn't affect the outcome, does it, with the 3 of a kinds? So instead of going 13, 12, which is really 13P2, it's a permutation, I'm gonna go 13C2 and do that all at once.
Oh, it's the very beginning. Oh. So
Put it in the middle if you want, but I do that because it's the same amount.
Oh.
Now, I didn't do 13C3 because look, right here, changing the order of what I picked for the 3 of a kind and 1 of a kind does make a different hand than that. But changing the order from the 3 of a kinds does not. So I've got to pick the 3 of a kinds. There's 13 different kinds to choose to be 3 of a kind. I'm picking 2 of them, same amount. Now that, I could say 11C1, or I could just say 11. Or actually, since I'm only picking 1 card, you could actually say 44C1. You're just picking one of their main ones.
Oh, and I guess that works because 11C1 is 11 and 4C1 is 4.
That's
and
right.
multiply to get 4.
You could write the number 44 in there if you want.
Why is it 44C1?
Because it just happens to work out mathematically. And because I don't care what kind it is.
No, because you used the 4 from the first, you can't hit the 4 from the first suit or the 4 from the second suit you used, so it's 52 minus 8.
A lot of the little rules relax when you're only picking one card because there's so many things that are equal to 4. I mean, 4C1 is 4, 4P1 is 4, 4 is 4. I mean, there's so many different ways to write 11 and 4 that you get a lot of different answers that end up being, that whole answer is 44. There's only 44 cards left, right? That aren't 10s and, that aren't whatever I picked here.
Okay, so you have to reduce, you pick the kind at the same time, so 13C2,
Because I had the same number here.
and then you do that, you put the same number twice, because you have to pick 3 of a kind twice. Like 3.
Correct.
And then there's just one random card that's not.
That's right. So if you have one random card, you could, if you want,
Okay.
say, well, there's 11 kinds left. Let me count the number of kinds I could pick from and then choose the card. Or you could go, you know what, I'm only picking one card. It doesn't matter. Why don't I just say all that's left, there's 44, I'm picking one. And guys, to me, this is the hardest kind of question I would ask. Like, this is the one people miss the most. So if you're getting this, great. I'm not going to ask you 20 of them like that. I'm going to check to see it. To me, that's worth about 7% of your test. So there'll be portions of a few problems that if you miss that portion, you might lose 7, 8 points if you didn't do it on all of them. But most of the time, I'm going to say, what's the probability of getting 3 kings, 3 jacks, and 1 other card? Well, in that case, did you even have to decide?
No.
No, I told you kings, 4C3. I told you jacks, 4C3. It's when you don't know that you have to do that. And when you don't know, just ask yourself the question, all right, I don't know each of those 3 of a kinds. That's the same amount. We'll choose the kinds for those 2 at the same time. Choose them from the 13. Don't go 13C1, 12C1. Because even though you'll feel in your heart and soul that that's a combination, 13C1, 12C1 is 13 times 12, which is a permutation. And you can't do that with those because the order in which you pick those 3 of a kinds doesn't affect your outcome.
So my thinking basically said, like, I'm reducing the amount of time, which is not exactly true.
Correct. And by doing that, you're changing the probability. But what you really did by doing that, you're saying, how many different ways can I get 3 of a kind, 3 of a kind, 1 of a kind, if the order in which I get those has an effect on the outcome? That's kind of what you said. Or if the order in which I get the kinds has an effect on the outcome. What else you got?
The B portion.
Yes, give me 2 seconds. A better way to say it would be this. It would be like me saying, hey, I need 3 of a kind, 3 of a kind, and 1 of a kind. How many different? No, I don't even know. I don't even know how to ask it.
Yeah.
Say it again, John.
The B portion. Any on the
What page?
probability and counting review.
Can you just give me the page?
Yeah, let me.
115.
115? Yeah, because I don't know which order they're in. So the B part of number 20?
Yeah.
Okay, so let me read. 7, 10, 13, you're drawing. Okay, now I told you in that order. So on this one, using fractions in that order, so the probability of getting a blue would be 7 out of 20. So that's getting a blue first. And then getting another blue would be 6 out of 19.
It's on 30.
And,
Yeah.
30, you're right. And then now I want 3 reds. So there's 10 reds. So 10 out of 28, it's a red. Then you want another red and another red. So 9, 8, 27, 26. And then your last one's a white one. There's 13 out of the remaining 25. So that's blue, blue, red, 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 white in that order. And if I wanted to do permutations, you would have had this. 7P2 times 10P3 times 13P1 over 30P6.
Well,
I guess it's just like the way that you group the action.
And I don't have to put the parentheses around.
Yeah, that's just like.
What did I do? Did I do that?
Yeah,
What did you do?
I just, when that happens, I just like, don't have any.
Oh, that's fine. Yeah, no, the parentheses mean nothing. I mean, I could have parentheses around every one. I could have no parentheses. I'm just doing that to kind of show, hey, here are my B's, here are my, you totally don't need to do that. Yeah, the times that you have in the middle of these is enough. And if I didn't say in that order, what do I do here? Combinations. What do I do here?
You do
I put the 6 factorial over
3 factorial.
2 factorial, 3 factorial, 1 factorial, right? Now what changes here when I say with replacement?
You can't do that.
Can't do.
I cannot do this. Can't, if it's with replacement, because it's independent. But I could still do this, but what happens? If I'm putting it back, it's just the same thing twice, right? And if then I have 10 over 30, but I'm putting it back, same thing 3 times, and then 13 out of 30, and nothing changes in the denominator because I keep putting it back. But again, I do not have that stuff in the front because it says, hey, in that order. And this is
Why
blue.
can't you use combination and permutation?
Well, because a combination and a permutation, the whole basis behind them, like this one right here, the whole basis is a factorial. And factorials only occur when the numbers decrease, right? But if I put it back, it's stuck at 7. So you don't even have the option there.
It takes away the options factor.
You could still have that, like, if I had not said in that order, I would still have 6 factorial, 2 factorial, 3 factorial, 1 fact. I would still have that in front because that counts the number of ways I can arrange those 6 letters, right? That's like saying, hey, how many words can you make up with those 6 letters? It's like Mississippi. Oh, 6 factorial, 2 factorial, 3 factorial, 1 factorial, because they're matches.
It turns it into like a combination. Right?
That feels like a combination, but it can't be with 3 numbers on the bottom. It could have been with 2 numbers on the bottom, maybe, but yeah. But no combination permutation. So there might be a factorial in the problem, but not what would have come from these P's. Yep.
On page 110, can you explain 12C?
Of course.
I just sort of like.
Okay. So 7 people arranged at a table. Now, a lot of times people see these problems and they go, Mr. Hurry, that makes no sense. Why does this happen? It seems like it should be less than that, but it's conditional probability. And conditional probability puts a condition initially and then asks you to find something or count something. This is not conditional probability, but it's like in conditional arrangements. So, because it didn't say probability. But when you're finding things, sometimes, like to me, it seems like if I said, how many people can you arrange at a circular table? It should just be 6 factorial, right? Well, this one ends up being 7 times 6 factorial, which is 7 factorial based on this problem. But you're like, wait a minute, there's only 6 factorial ways to do this. It hurts the brain a little bit, but it's because there was a condition put on it. So just resist the problem, resist the feeling of distress if you get it. Because this says this, like let's just say there was a wall with a door. Okay, so an open door, and there's our table, and there's a chair nearest the door. Right? That's what it says. And it says one of these 7 has to sit there. And the rest of them can sit in these other 6 chairs, right?
Oh, but it
There's
doesn't lock
7
one of
ways.
the 7 in each.
Yeah, but it didn't say which of the 7 are going to sit in that one chair. All right, it doesn't. So how many options initially do you have to sit in this chair?
So
7.
times 6
Now,
factorial.
Once you pick that person's stuck there for the duration, right? So now you're saying, well, how many people can sit in these 6? But what is that person acting like, stuck in that chair?
Class.
Like a class. So you have 6 left to arrange here, 6 factorial.
At that point, they're basically like in a line. It's like organizing 6 people
That's
in
right.
a straight line. So you can ignore the like circle.
Wait, so you know when you divide by 2?
That would be if it's flippable.
Okay, so if there's no class for those?
No, it could have a clasp or not have a clasp. But if it's flippable, like for instance, if I could take my watch off and flip it, and it'd be exactly the same, Now it's not because it's suddenly 627. No, yes. But if I could, then it would be flippable, like a necklace. The only things I can think of are like necklaces, bracelets, key rings. And I'm sure you could think of something else, but I can't off the top of my head. But things that you could take, flip off, and now the order looks different, but I really didn't arrange anything, did I? I didn't actively take stuff and move it. So flippability is completely separate from circular, although things that are flippable often are circular. But if it's flippable, which are normally those three things, just divide by 2, whether it has a clasp or doesn't. So every necklace, I would divide by 2. Every bracelet, every key fob, I'm going to divide it by 2 because it's flippable. Whether or not it's circular depends if it has a clasp or something that acts like a clasp. But tables, can't flip that. You can't go, you know what, I want you on this side and you on this side. Stay put. Bam! Thank you. That's not going to happen. What else?
On 114 for number 16, I set it up, but I have a question.
114, number 16?
Yeah, so I did like 0.15 to the fourth and then 0.85 to the first.
Okay.
And it says, it was like second quarter of the
So are you saying that you think that's good right there?
Yes.
Okay, so what you just said by writing this is you said, what's the probability that I get rain, 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 not rain? But if you stop there, what you just calculated was the probability of getting rain on the first, rain on the second, rain on the third, rain on the fourth, not rain on the fifth. And if I specified that that's what happened, that it only rained on the 5th day, you would stop.
So
But-
I do 5 factorial or 4 factorial.
Right, which is like me saying, hey, how many new words can you make from that? You'd say, kind of like Mississippi, there's 5 factorial total word, 5 total words, so 5 factorial. 4 of that, though, I got to divide out that 4 factorial. That's essentially what I'm doing. I don't have to put the 1 factorial, but
So how do I know like when to add that? So when it, do I have to, for every problem, I have to think like, well, did I calculate it in that order?
yes, yeah. Like if you look at a problem and the order in which something happens has an effect on the outcome like that. If I specify that it has to happen in a certain order, like whatever I told you to find, then you don't want that. If I don't specify it, you do want it. So like if I'm playing cards with kings and queens and jacks or whatever, and I say, hey, what's the probability of getting this in that order? Well, you don't want to use C's. You want to use P's, or you want to forget this.
So like if it asked for like the first 3 days of the week and then the others were like not rain, then I wouldn't have to do that.
You would not do that. If I said it rains on the first 3 and doesn't on the next 2, you stop right there. Because that literally just calculated 0.15 on Monday, 0.15 on Tuesday, or whatever day, 0.15, then 0.85, then 0.85. In that order, that would be the probability that it happens.
Can you just say real quick what, like the circular, if you just have a circular table and you have 6 people, how many ways?
5 factorial.
That's it. That's all you have to
Just
do.
subtract 1.
And then when if there's a clasp on a key ring, you don't subtract 1
Correct.
and you divide by 2. Still, because it's a key ring.
Because it also happens to be flippable.
Why does a clasp not make you subtract? Like, why does the clasp?
Did you watch this video?
No, I was here for that day.
Okay.
I was here for that day. I just didn't understand.
Well, so ask it again.
Why does the clasp take away the -1?
Well, the class takes away the -1, doesn't really take it away, because that's how we've always been arranging stuff. Right? I mean, every time I arrange something online, like if I open up a necklace, right, and I say, how many ways can you arrange these beads? And there's 6 beads. Well, it's 6 factorial ways to arrange those beads, right? But by putting circular in, it's not like I got rid of the -1. It's when I make it circular with no clasp. For instance, like if I had, let's just say I had A, B, C, D, I had 5 different beads hanging on there or whatever on a linear situation. Well, that's 5 factorial, right?
Yeah.
Well, in this order, isn't there another order that looks like this? Like, wouldn't I have counted this right here?
Oh, we don't count that in a circle. Never mind. Yeah, I'm good.
Are you with me?
I just didn't.
Yeah, because if I join these, then if it's a circle with no clasp, I could take this E and just swing it around, and now it's over here, and I have that. But I didn't change the order. I just looked at it from a different perspective on the circle. I didn't actually physically change it like I would if it was on a line. Are you with me?
Yeah.
It was already like that. I just looked at it differently. So I got the same result. But if there's a clasp back there,
It turns it into.
then I can't swing that E around. It hits. So the E acts linear that way. So I have to stay with 5 factorial. But if there's no clasp, all those results, like me swinging the E around and getting a new circle, well, it wasn't really new. So I don't want those. And the way to account for those is to go 4 factorial when it's circular. But if there's a clasp, it's just linear. So it's not like, why do I get rid of a -1? And it's not that. It's why do I have a -1? It's special for a circular situation that's not clasped or locked in by something like that.
I just didn't think about the clasp as like turning it into linear until you physically draw something.
Yeah, and it's really easy to remember that because if you undid the clasp and stretched out, you have a linear.
Yeah.
But if it's circular, I can that's the same thing. I don't have to change anything. I just wear it differently.
You still swing the D around, and D, E, A, B, C is the same thing.
That's right. So why would I count all those? It's the same thing.
Yeah.
So, but why does it end up being 4 factorial and not 3 factorial? Why does it end up being -1 factorial? I haven't really looked at the science of it. I just looked at enough examples where I had confidence. Yes.
So I think I know the answer to this, but just to make sure, when you're doing something probability, something like a deck of cards or a hand of cards, and you do C's, you don't have to put the thing out front, right?
Right, because it already has it in there.
That accounts for it.
Yeah. Like when you have 5C2, let me make it make sense. If you have something like 4C2, 4C1 over 52C3, the difference between that, 4P2 and 4P1 and 52P3, this doesn't have the same thing as this, because you remember in the definition of C and the definition of P, we go 4 factorial. In both definitions, we go 4 minus 2 factorial on the bottom. But in this, we also have a 2 factorial on the bottom. In this one, right? So it's already in there. This does not have that extra 2 factorial on the bottom. But if I put an extra 2 factorial on the bottom, and an extra 1 factorial on the bottom, and an extra 3 factorial on the bottom of the bottom of the bottom ends up being the top. These are now the same. They just are. And if I simplify this even more, 4P2 is 4 times 3. 4P1 is 4, and 52P3 is 52, 51, 50. And that's one way to write it. That's another way to write it. I rarely would ever write it like this, but you could, I guess. But I don't need to because the C's take care of that part out front. But if I'm writing it like this, I'm technically writing it like a permutation. I may not realize I'm doing it, but I'm doing it. And I'm writing it like a permutation because 4 times 3 is 4P2. 4 is 4P1. This is 52P3. So to turn the permutation part into a combination, I tack those extra factorials on the front. That's why I do it, because I'm just trying to make a match. But if I said in that order, don't do this, you don't need that. You don't need that. That's in that order. That's like saying 2 kings and a jack in that order. Then I don't need that stuff because I want king, king, jack. All right.
It's slowly starting to click a little bit more.
What else you got? Yep.
Page 117. Can you do 4?
Yep. Find the probability of getting a 5, a 2, and a 4 if I roll 3 dice.
The common, is it a combination?
It's just 1/6.
I just did 3 coming. 11, 7, no, 4. just like
Oh, wait.
1/3
Yeah, isn't it 1/6 of 30?
of 6, no.
No, because then you're saying in that order, if you should the third.
Yeah, I didn't say in that order.
It's a combination.
So think of it like 5, 2, and a 4. Okay? So probably getting a 5, 1 in 6. Probability of getting a 2, 1 in 6. Probability of getting a 4, 1 in 6. But there's 3 factorial over 1 factorial, 1 factorial, 1 factorial ways to do that. Or you could just count up FTR, FRT, TFR, and just kind of go through all 6 of those. But that's what that's going to do. That's 6.
6C1Q.
I can't do combinations on this because, oh, well, 6C1 is 6. So the bottom, yes, is 6C1 cubed technically, but I'm not even going to think about combinations.
Don't bother with that.
Wow, it's independent. It just becomes more confusing.
Does a pair match in suit or kind?
Pair will match in kind. There's nothing
There are
about
13
suits.
kinds and 4 suits,
Correct.
right?
So a pair would not be like 2 hearts. It would be 2 kings, 2 jacks, 2 tens. The only way hearts really matter is if you're dealing with a flush, and you would need all 5 to be a flush. So 5 hearts.
A flush is 5 cards. Flush isn't.
A flush is 5 of the same suit. So like 5 hearts, 5 spades, 5
It
diamonds.
says like maybe like 7 cards and like 5 is like there's a flush in there. 5 of those will have to be.
At least 5. 5 or 6 or 7.
And so that's when you add.
If you had an at least situation or something that suggested that, yes. And honestly, if you get to the thing and you're like, I don't know what a full house is, and I didn't explain it, just come ask me. I don't want this to be about your knowledge of poker. Okay? Or if you're like, I forgot what a flush was. I probably will say in the problem, but should I forget? I mean, we've talked about it a bunch, but if you forget, whatever, just come ask me. I'm not going to go -5 because you don't know how to play poker. I mean, I'm not going to do that.
You can only take away 3.
That's right. It's just, that's not what's important to me. It's the math, not your ability to know cards, because that's not fair. I mean, this is not a cards class, although you wouldn't get that kindness I mean, if anybody's talked about something in a normal class, they would expect you to know that. And it's always good to know. I mean, you never know what kind of family you're going to marry into. I mean, my family is half Italian. And dude, you go to the Italians for anything, weddings, funerals, engagement dinners, it does not matter. Within an hour and a half of the pleasantries, somebody's breaking out a deck of cards and poker and a lot of cash. Every time. And they'll play till 4 in the morning. 77-year-old dudes out there. And I mean, like my Uncle Paul, God rest his soul. All mine were Paul, Tony. I mean, it was like I was going to, what's that mafia movie? The Sopranos. But my Uncle Paul was this charming, enormous human being most of his life. This big 400-pound Italian guy. He did slim down to about 240 before 5'10", 240. He was a big fella. But he
was 5'10", 400.
400. Huge. It's amazing he lived as long as he did. But loved life more than he did. It's truly a pleasure to know. But he could play at a table of 10 people. When he dealt the cards, he dealt them like this. He'd be like, he would float helicopters to your seat.
That's so cool.
It was awesome. Like everybody else is like, shuffling, sliding them and missing and whatever. And he's like, they're just like, he was a wizard. He was awesome. But yeah, you have to marry a family like that. You got to know how to play your cards. Right? You don't know how to play cards. You're going to be like, well, first of all, they're going to take all your money every time. I knew how to play cards, and I'd go in there, and they'd steal from me, man. When I was young, my grandfather would always give it back to me. But, man, uncles, no. They're taking your money, giving it to their kids.
My uncle's wedding, like all the adults played cards.
In Italian?
Yeah.
Oh, what am I kidding? Yeah, suppose that. Of course. Italians love cards, man. My grandmother would be like canasta, but no, all the dudes. And my girl cousins, dude, they can play. Oh, I mean, they could play. You like straight-faced poker. take you for all you have. You gotta be on your toes, man.
I feel like you're just warning us for life because you've lost so much money.
No, I have not lost money, but I have lost probably
Guys lost.
80% of the time I played with my uncles, I'll lose. They're good. And you don't even see it coming. They're so charming and they're funny and they're laughing and living in revelry and all this kind of stuff. And all of a sudden, what? I did not see that coming. You just
You
can't.
weren't here for the Sasita story.
No, it was no.
Sasita? He's not a relative though.
Your friend.
Yeah.
Oh.
Said, I heard you referencing that, and I was like, what are you talking about?
What else you got, guys? Yes.
Number, 114, or page 114, number 19. I did it wrong. I said,
Okay, so essentially what you're going is pair. So you're getting two of a kind, one of a kind, right?
wait. What did it say?
It's
Oh.
a game of 5-card poker. I'm down
Yeah,
2 pairs.
So you got to account for all 5 cards.
I just did 4C2 times 4C2 over 52C4.
Okay, so here's what you found. 4C2 times 4C2 over 52C4 would be what you would have if I said, what's the probability of getting 2 kings and 2 queens? Or 2 jacks and 2 tens? But because I would have told you jacks and tens, you didn't have to count all the different ways of getting those kinds because I told you which kinds to pick. Now, the big mistake, one of the mistakes you made is I did say it was 5 cards. So there's another card. You picked 5. So you've got to account for this other kind, this 4C1. I'm sorry, you're going to pick one more kind. I'll do it this way, and then I'll talk about other ways you could do it. So this is me picking, this would be like me picking jack, jack, queen, queen, 10, right? 2 of a kind, one of a kind. But I did not tell you which kinds they were going to be. So here's the next mistake people make. People come in here and they go, well, if I'm not going to tell you what kind, then you're going to say, well, there's 13 kinds of picking that first 2 of a kind. And then once I pick that, there's 12 ways to pick that second. And I'm multiplying here. And then you would say there's 11 ways to get that third. But the problem with that is this is saying 13 times 12 times 11, which is a permutation. It's 13p3. And like we said with 3 queens, 3 jacks, 3 jacks, 3 queens, isn't that the same thing? Now, are 3 queens, 1 jack, 3 jacks, 1 queen the same thing? No. So when I have different numbers, then I can say, oh, 11 times that, that's fine. Or in this case, 11C1. But guess what? 11C1 is 11. So I could have said 11 and it's close. But this, I can't say 1312. Because king, king, queen, queen, that's not different from queen, queen, king, king. So why am I acting like it's different by going 13 times 12? That means this. That's bad. I don't want that. I want a combination. So don't do that. Say 13C2. I am picking, this does not count those as different. Oh, that's the same thing. Combinations, the order in which I get those 2 of a kind or choose them doesn't have an effect on the outcome. 13C2. But because this one was a different amount than those, 11C1. If I had said, Sonny, if I had said 3 pairs in a 6-card game, I would have said 13C3. And I wouldn't even have had that. And then I would have had 4C2, 4C2, 4C2. But because that amount, I have 1 of those and 2 of those, I've got to choose these 2 from the same combination.
So the reason you like skipped 12 is because like the 13C2 you
Would have picked 2 of the 13, right? And there'll only be 11 left.
Okay.
But didn't you just say for that last bit, 44C1?
In this case, you get a lot of freedom when you're picking one card. You could say 11C1, 4C1. You can say 11 times 4C1. You can say 11 times 4. You can say 44. You can say 44C1. They all mean the same thing, and it's primarily because there's 1 card there.
What if you're picking 2 other cards?
Then that would, well, it depends if I said 2 other cards. If that's the case, I would say 44C2.
Then it's still fine.
But if I said 2 other different kinds of cards,
And you,
then I'm saying 1 of a kind, 1 of a kind. And if I meant that, then I'd pick 1 of a kind, 1 of a kind. But since it's the same amount, 11C2.
Wait, why is it 11?
It's not. I'm just saying if it had been, this problem's not. But if I said, because I've already picked 2 of the kinds, so that gets me from 13 to 12. So if I had to have 2 other different kinds of cards, they had to be different kinds than these. So I have to pick them from different kinds. But there's a lot of different ways I could pick different kinds. So there's 11 left after I've chosen these 2 kinds. So 11 left, but I got to pick both at the same time. I don't go 11 for this and 10 for that. That's a permutation. I would go 11C2 since I had the same amount of each.
So what if I asked you for another 2 cards?
Just a random, any 2 cards?
No, 2 of a kind.
Oh, another 2 of a kind?
Can you do 9C2?
If I said another 2 of a kind, then that would be 6 also. Then I would say there's another 2 of a kind, but 2, 2, 2, 13C3. Because there's 3 that all have the same amount, so I'm going to pick those 3 from this all at once. Because think about it, aren't these all the same? Right here, aren't those the same hands? Yeah, I'm not getting different hands by picking them in a different order, so pick them all at once. Y'all with me?
Yeah.
Sleepy heads?
Just a month.
It's not me today. So proud of me.
James.
Whenever he says, "Are you still with me?" The first row turns around and screams.
No, usually it's Andrew.
I
Listen to the-
I go for Andrew first.
It's the, y'all are like the 3.
It's
worst
Andrew,
strangers.
James, and Carson.
We'll go with that.
And Mary.
I say Mary flies under the radar a little bit because her head doesn't bob like
Or she
Andrew
lives
does.
outside.
My head doesn't even bob. It goes straight down. It's just bad.
Well, that's because I'm trying to.
There was a girl named Kirby,
It's like great.
Kirby something. She was this wicked good athlete. I think she was 5'5" in 4th grade and athletic.
Wow.
Dominated everything, never grew another inch. So like she was like a dominant force in every sport.
Wait, how tall is she?
In 5'5" or 5'4" in 4th grade, was huge, strong, muscular, powerful, never grew another inch. But she would get I had her in the 10th grade math team, and then she took regular pre-calcs back when I taught regular pre-calcs because she didn't want it to mess with her sports and stuff. She was so bored. I mean, every day, I don't know how she didn't hurt herself. She'd be like, and every time she would like do that, the head would whip, and she'd do the little left-right glance, like, anybody see me? And then it'd be like,
It's the worst when you're like, when you know you're gonna fall asleep,
Yeah.
but you know there's also an important lesson, so you're trying.
That's the worst feeling. Like when you're.
Oh, that's what I do in first grade. I'm just like,
What you were saying about like the hurry video, that's so true. Like whenever I'm falling asleep, I feel like
now
I'm
you're playing
watching
it in your head.
And then you'll say the classic, is everyone still with me? And I'll be.
Yeah, once you mention something about it,
I
then
know.
we go.
It's like, that's not in my movie. I used to struggle driving. Now I didn't used to drink coffee. Now I can just drink some coffee.
don't act like that.
I used to like doze. I remember driving home to Auburn, from Auburn, and like smacking myself in the face. I'd be like, I could not stay awake. I'd be like, wham, and I would hit myself.
When I'm driving to
I could not
work,
put my head out the window. It'd be like 20 degrees out.
when I'm driving to work and
So-
it's like really early and I have a bad night's sleep, I'll be doing, I do the same thing, but I'll do it really hard. And if like I'm putting my mask on as I'm walking in, like I think my manager thinks I get like beat. Because there'll be like hand marks on my face. It'll be from me.
That's hilarious.
I did that chemistry having our last night. I got like
Nathan.
72.
I got a 33.
Nice.
3.
And it was like 11:30, and I was like,
On what?
Stupid chemistry practice quiz. I got 100 on the first one, 33 on the second one, and I actually did the work. She actually did the
I didn't
work.
Actually, you're talking about ACT scores. So you go, good job.
Hey, guess what I got on the math portion? I got 36 on the math portion. But I got it really bad on the reading.
Yeah, I did too.